Good morning, students. Okay, yesterday discuss the shorter distance between the lines. Okay, first definition is skew lines. Skew lines. Skew lines. Okay, two straight lines which are neither parallel nor intersect. Okay, two straight lines which are neither parallel nor intersect are called skew lines. Or two non-parallel lines which do not intersect are called skew lines. Okay, write the definition. Two straight lines, two straight lines which are neither parallel nor intersect nor intersect are called skew lines. Are called skew lines. Okay. Two skew lines are never coplanar. It's clear that two skew lines are never coplanar. Are never coplanar. Are never coplanar. Or another one same. Two non-parallel lines. Two non-parallel lines. Two non-parallel lines which do not intersect. Which do not intersect are called skew lines. Are called skew. Okay. Two non-parallel lines. Two non-parallel lines. Okay. Two non-parallel lines which do not intersect are called skew lines. Okay. Next, given two lines in the space. First one, two lines are intersect. Two lines are intersect. Second one, two lines are parallel. Two lines are parallel to each other. Third one, two lines are non-parallel. And non-intersect. First two cases are two lines are coplanar. Two lines are intersect. Actually, two given lines in the space, three possibilities are there. Two lines are intersect. Two lines are parallel to each other. Two lines are parallel to each other. And two lines are non-parallel and non-intersect. First two cases are what? Two lines are coplanar. Two lines are coplanar. These two cases. But third case is two lines are non-coplanar and non-intersect. Then it is called as skew lines. Okay, and are non-coplanar. These two lines are what? Non-coplanar and also known as skew lines. Okay. Next definition, line of shortest distance. Line of shortest distance. Line of shortest distance. Line of shortest distance. If L1 and L2 are two skew lines, L1 and L2 are two skew lines, okay, then there is one and only one line perpendicular to each of the lines. Each of the lines L1 and L2 is called the line of shortest distance. Line of shortest distance means if two skew lines L1 and L2, if two lines, if L1 and L2 are what? Skew lines, then there is one and only one line perpendicular to the each of the lines L1 and L2. Okay, which are known as line of shortest distance. Next, only shortest distance. Next definition, shortest distance. Shortest distance. Shortest distance is the shortest distance between two lines is L1 and L2. Is the distance PQ. Is the distance PQ. The shortest distance between the lines L1 and L2. Okay, between two lines L1 and L2 is the distance PQ. The shortest distance between the lines L1 and L2. The shortest distance between two lines L1 and L2 is the distance PQ. Is the distance PQ. Where P and Q are the points of intersection of the lines. Okay, where P and Q are the points of intersection of the line of intersection of the line of shortest distance. Line of shortest distance with the given lines. With the given lines. Okay, the shortest distance between the lines L1 and L2, okay, is the distance PQ. Where P and Q are the points of intersection of the line of shortest distance with the given lines. Line of shortest distance, if L1 and L2 are two skew lines, then there is one and only one line perpendicular to each of the lines L1 and L2, which is known as line of shortest distance. If L1 and L2 are two skew lines, then there is one and only one line perpendicular to each of the lines L1 and L2, which are known as line of shortest distance. Okay, which is known as the line of line of shortest distance. Shortest distance. Okay. Next, the skew lines L1 and L2 are there. Next, that distance, if two lines are intersect, then shortest distance them is what? 0. When two lines are intersect, then shortest distance them is what? 0. When two lines are intersect, then shortest distance them is what? 0. Okay. Next, derivation. Derive the expression for the shortest distance between two skew lines, both vector and Cartesian form. Derive an expression. Derive an expression for the shortest distance between the two skew lines. Between the two skew lines. Derive an expression for the shortest distance between the two skew lines, both in vector and Cartesian form. Okay, proof. First you listen here, note right. Derive an expression for the shortest distance between two skew lines. Okay, if two lines are given, then find the shortest distance between the lines. Not mention skew line and parallel lines. Okay, 3 marks problems are very important in this part. Okay. Two skew lines L1, L2 and parallel to the line B1 and B2 vector. This is B1 vector. B2 vector and line of shorter distance. The line L1 passing to the point S. The line L2 passing to the point T with position vectors. A1 vector with the position vectors of the point S, and A2 vector is the position vector of the point P. Okay. Let B1 vector and B2 vector, B2 vectors B2 vectors, B2 vectors. Okay, and parallel to the lines, B2 vectors parallel to the lines, L1 and L2 respectively. Okay, if two lines L1 and L2 and parallel to the vectors B1 and B2. This means B1 vector and B2 vector mean two vectors parallel to the lines L1 and L2 respectively. Stop. Let A1 vector and A2 vector be the position vectors. A1 vector and A2 vector be the position vectors of the points S and T. Respectively on the lines L1 and L2. On the lines L1 and L2. Then two lines are what? Then the two lines. Then the two lines B. L1 line is the line passing through the point. Equation of line is base passing through the point, and parallel to the vector is what? R vector is equal to A vector plus lambda into B vector. First, the line L1 passing through the point is S, and parallel to the vector B1. Okay. Now R vector equal to, there are two lines, A1 vector plus lambda into B1, and second line vector equation is R vector is equal to A2 plus mu into B2. Next, you are taking PQ is the shortest distance between the lines. PQ. Next, we will draw. PQ is the shortest distance between the lines L1 and L2. PQ is the shortest distance between the lines. Like PQ is the shortest distance between the lines L1 and L2. Shortest distance between the lines L1 and L2. Next, the shortest distance between two skew lines is equal to projection of ST on PQ. The shortest distance between two skew lines is equal to what? Projection of ST. on PQ. Projection of A on B formula: A vector dot B vector divided by magnitude of B. We have shortest distance between two skew lines. The shortest distance between between two skew lines, can be written as ST vector dot PQ cap. You know this, projection of A vector on B vector is equal to A vector dot B vector divided by magnitude of B. A dot B divided by magnitude of B means that B cap. Okay, A vector divided by A vector divided by magnitude of A vector is A cap. Okay, this means B cap. Projection of A on B is what? A dot B cap. Projection of ST on PQ is what? ST dot PQ cap. ST dot PQ cap. Now we have to mention this is equation 1. Next, you have to find ST. ST is using vector joining 2 points. AB vector is what? OB minus OA. ST is equal to what? OT minus OS. Okay, now A2. A1 and A2 are the what? Position vectors of the points S and T. OS is equal to A1. OT is equal to A2 vector. Equal to both L1 and L2. And also B1 because these two are what? Parallel to the vectors, parallel to the line B1 and B2. B2 is perpendicular to L1 and L2 and also perpendicular to both B1 and B2. Using unit vector perpendicular to both A vector and B vector. Unit vector is perpendicular to both A vector and B vector. And in a vector product or cross product of two vectors. That I am telling unit vector perpendicular to both A vector and B vector is given by what? N cap is equal to A cross B divided by magnitude of A cross B. This one is what? PQ vector is PQ cap is the unit vector perpendicular to both what? B1 and B2. PQ cap is B1 vector cross B2 vector divided by magnitude of B1 cross B2. Okay. Next, we have to find PQ since PQ vector is PQ is the perpendicular to both. PQ vector is the perpendicular to both L1 and L2. Also perpendicular to B1 and B2. PQ vector is also perpendicular to B1 vector and B2 vector. B1 vector and B2 vector. Okay, this implies PQ cap is a unit vector. Perpendicular to PQ cap is the unit vector perpendicular to both B1 vector and B2 vector. B1 vector and B2 vector. Therefore, PQ cap is equal to PQ cap is a unit vector perpendicular to both B1 and B2 vector. PQ cap is equal to B1 cross B2 divided by magnitude of B1 cross B2. Okay, substituting ST vector and PQ cap in equation 1. Then we will get shorted distance between two skew lines. Okay, because N cap is the unit vector perpendicular to both A vector and B vector is what? N cap is equal to A cross B divided by magnitude of A cross B. Okay, using this. Okay, PQ cap is a unit vector perpendicular to both P1 and P2 because PQ vector is perpendicular to both L1 and L2 and also PQ vector is perpendicular to B1 and B2 because parallel to the vectors B1 and B2. Okay. Therefore, next is substituting ST vector and PQ cap in equation 1. Okay. And as it is, B1 and B2 two vectors are parallel to the lines L1 and L2 respectively. Next, A1 and A2 be the position vectors of the points S and T, respectively on the lines L1 and L2. Then two lines L1 vector equations. This is the vector equation. This one is what? Vector form. Vector form. This one is what? Vector form. Next vector equations are L1 is R vector equal to A1 plus lambda into B1. L2 is R vector equal to A2 plus mu into B2. Next PQ is the shortest distance between the lines L1 and L2. We have shortest distance between two skew lines is equal to ST and PQ. ST vector is equal to OS minus ST is equal to OT minus OS because A1 and A2 are the position vectors of the points S and T. A2 minus A1 ST will get. Next PQ vector is the perpendicular to both L1 and L2 and also perpendicular to both B1 and B2 because parallel to the lines, parallel to the vectors B1 and B2. PQ cap is a unit vector perpendicular to both B1 and B2. Therefore, PQ cap is equal to PQ B1 cross B2 divided by magnitude of B1 cross B2. Substituting XT and PQ cap in equation 1. Okay. D is equal to ST dot PQ cap. ST vector is A2 minus A1 dot PQ cap is what? B1 cross B2 divided by magnitude of B1 cross B2. Distance, it should be positive, modulus of A2 minus A1 dot B1 cross B2 whole divided by magnitude of B1 cross B2. Okay, this is the vector equation of the shortest distance between two skew lines. Okay. Vector equations are given. Two vector equations are given. Then find out shortest distance between the lines. Okay. First you have to take in A1, A2, B1, B2, A2 minus A1. First find out how to find B1 cross B2. Cross product of two vectors. A cross B is equal to what? Determinant of first row is A, second row A components, third row B components. Next magnitude. This is vector equation for the shortest distance between two skew lines. Next, Cartesian form. Next is Cartesian form. Cartesian form. In this part, only 3 marks problems are important. Okay, using this formula, two vector equations are given. Then find out shortest distance between the lines. The shortest distance between the lines. The shortest distance between the lines is L1 is two vector equations A1 plus lambda into B1. First line is x minus x1 divided by vector equation. Cartesian equation is what? The line passing through the point line parallel to the vector. X minus x1 by a equal to y minus y divided by b equal to z minus z divided by c. x minus x divided by a1 because two lines. a1, b1, c1 are the directions of first line. a2, b2, c2 are the directions of l2. Y minus y divided by b1 equal to z minus z divided by c1 and l2 x minus x divided by a2 y minus y divided by b2 z minus z divided by c2. These two lines, short addition between the lines, partition form, where a1, b1, c1 are the directions of first line. The first line passing through the point x1, y, and z. The second line passing through the point x2, y2, z2. Second line direction are a2, b2, c2. Let a1 vector is equal to the line passing through the point. Yes, with position vector is what? a1. a1 is equal to what? x1i plus y1j plus z1k. b1 vector is equal to what? a1i plus b1j plus c1k. a1i plus b1j plus c1k. Next, a2. The line L2 passing through the point is what? T. Okay. Yes, T. Okay. A1. A2. Okay. Parameter the vectors B1, B2. A2 is what? X2i plus y2j plus z2k. B2 vector is what? Direction of second line. A2i plus B2j plus C2k. C2k. We are takes the vector form A2 minus A1 dot B1 cross B2. First we have to find A2 minus A1. A2 minus A1. Because vector equation of the form is A2 minus A1 dot B1 cross B2. Takes the vector form A2 minus A1. x2 plus xy plus y2j plus z2k minus of x1i plus y1j plus z1k. This means x2 minus x1i plus y2 minus y1j plus z2 minus z1k. Or one step, x2i plus y2j plus z2k minus x1i plus y1j plus z1k. A2 minus A1 equal to x2 minus x1 I plus y2 minus y1j plus z2 minus z1k. Next we want B1 cross B2. B1 cross B2. And we have to find B1 cross B2. This is of the form of A cross B, vector product of two vectors. Determinant of first row unit vectors I, J, K. Okay. Second row B1 components. B1 components are A1, B1, C1. A1, B1, C1. A2, B2, C2. Okay. Expanding along R1, determinant I into first row first column delete B1 into C2. B1 into C2 minus B2 into C2. B1 into C2 minus B2 into C2. A1, B1, C1. Okay, B1, C2 minus B2, C1. I minus J into first or second column delete A1 into C2. A1 into C2 minus A2 into C1. into j plus k into first or third column delete a1 b2 minus a2 b1 into k into k. This is b1 cross b2. Next we have to find magnitude. In denominator is what? Magnitude of b1 cross b2. Okay, b1 cross b2. This is a big form xi plus yz plus zk. Then magnitude is what? Root of x square plus y square plus z square. Root of b1 c2 minus b2 c1 whole square x square minus y whole square can be written as y square plus a1 c2 minus a2 c1 whole square plus a1 b2 minus a2 b1 whole square. This is magnitude of b1 cross b2. And also we have to find numerator is what? Vector equation takes the form a2 minus a1 dot b1 cross b2. All three find out. a2 minus a1, b1 cross b2 and magnitude also find out. We can taking we have a2 minus a1 dot b1 cross b2 a2 minus a1 is what? a2 minus a1 x2 minus x1i plus y2 minus y1j plus z2 minus z1a dot b1 cross b2. b1 vector is a1i plus dot b1i plus a1i plus b1j plus c1a. Okay, cross a1i cross b2 vector. b2 vector is a2i b2j plus c2k. a2i b2j c2k. Once again write down a2 minus a1 equal to x2 minus x1i y2 minus y1j z2 minus z1 dot b1 cross b2. b1 is a1i plus b1j plus c1 cross b2 vector. b2 vector is a2i b2j plus c2k. After that, this is the big form of a dot b cross a, scalar triple product of three vectors. Scalar triple product. This is the big form of a dot b cross c. A dot b cross c is equal to what? Determinant of first row a components, second row b components, third row c components. A means what? A components are what? x2 minus x1, y2 minus y1, z2 minus z1 are the first row components. Second row a1, b1, c1, third row a2, b2, c2. Equal to first row x2 minus x1. This is the form of xi plus yz plus zk. Components are what? This vector x2 minus x1, y2 minus y1, z2 minus z1. y2 minus y, z2 minus z. Okay, second row components A1, B1, C1, A2, B2, C2. This is A2 minus A1 dot B1 cross B2 is equal to what? Determinant of first row X2 minus X1, Y2 minus Y1, Z2 minus Z1. Second row A1, B1, C1. Third row A2, B2, A1, B1, C1. Third row A2, B2, C2. All are substituting in vector form. Okay. Okay. Now D is equal to vector equation takes the form D is equal to A2 minus 7 dot B1 cross B2 is determinant of X2 minus X1, Y2 minus Y1, Z2 minus Z1. Second row A1, B1, C1. Next A2, B2, C2. A1, B1, C1. Second row A2, B2, C. D is equal to whole divided by magnitude of B1 cross B2. Magnitude of B1 cross B2 already find out. Root of A1 B1 into C2 minus B2 C1 whole square plus A1 C2 minus A2 C1 whole square plus A1 B2 minus A1 B2 minus A2 B1 whole square. Okay, this is the Cartesian equation for the shortest distance between two skew lines. This is Cartesian equation for shortest distance between two skew lines. Vector equations are important. D is equal to A2 minus A1 dot B1 cross B divided by magnitude of B1 cross B. Okay. Tomorrow, this is the problems based on shortest distance between two skew lines. Only problems are important in this part. Okay, based on this part problem, based on this theorem. Okay. Next, another one derivation is there. Shortest distance between two parallel lines. Shortest distance between two parallel lines. This one is not skew lines. Over. Next we will discuss exercise 11.2. Okay. Thank you. ಇದು theorem ಮೇಲೆ important ಏನಿಲ್ಲ.